My name is John Dickhoff, and I'm a hardware engineer for Intel. And this presentation is a look inside, if you will, of how I use Perl to glue together all the steps in our hardware design flow. And maybe this is just a review for everyone, because I'm really doing the greatest hits of what Perl is good at. And you might ask, why is a hardware engineer giving a talk on Perl? I thought this was a software conference. I've heard people denigrating hardware design, and it was just too difficult, so I ran away to the computer side. But I started on the computer side. I was a C programmer way back when, and we used Perl, an old version in the late 80s, to wrap around CI and CO, the RCS commands for primitive pre-get, long before get, revision control. And I had a coworker who did that, and I helped him. And then we made our R&D staff a little bit happier. And you go forward in my career, I eventually did become a hardware engineer. And there, again, a colleague used Perl. This was a different version of Perl. Had all this stuff I hadn't really seen before. And he would usually design the code, and then I would test it out and make it work at the chip level and whatnot. But then I've been in Intel now for 3 years, and I went there, Perl and I have gotten really close. And I really use it as a job aid, make my life easier, make our groups work easier. I could sit back and let other people develop Perl, but in this group filled with hardware designers, I'm the software person. I need to develop it, so that's what I've done. And what I did is I took this 20-page Word document, or PDF, that supposedly described the steps. If you had such a document for your software design, you think you could give your new college grads that document and have them reasonably complete anything? This document is only useful for people who already know the steps and don't need the document. So I thought, if I could put that in Perl, I need to have a little bit of time to do it, that I could make the team more efficient, let the junior engineers get a lot of work done, be productive. We still might have to help them with the complex stuff, but there's no harm in that. And that's what I did. I don't know. So raise your hand if you're a hardware engineer. Just
used to be.
Just, okay. Okay, that's why I put this slide in there. How many people, in contrast, have seen Interstellar? Okay, 2 people, so 100% increase.
That's market.
Okay, on this slide, if you haven't seen the movie, I don't want to spoil it, but one of the plot drivers is the way that people experience time differently. And I'll just rephrase it this way. How many releases of software could you produce in a year if you were, what do they call it now, a software as service kind of thing, where it's like your choice. You could do it once a week if you wanted, right? How many hardware releases do you think a company could do in a year? 1, if you're lucky. So the scale is different. The underlying tools are different. Waiting overnight means it runs fast for hardware designers. We have tasks that take all month to finish. That's after we parallelized it and split it up into smaller tasks. So I'm not going to try and turn you into hardware designers. I'm just going to show you some, if you will, points that I ran into implementing the Perl. And maybe when you have to string together a whole bunch of stuff, you might run into it. So I used GetOptions before, and I was going to have an option for each step. And going in, I didn't realize we were going to have 23 steps. 23 step is check-in. To use the Getism, it's called committing. But I got in thinking, oh, I'll put the number and then some little text, and they could use that and they would remember it. But people have a hard time remembering a phone number. They're going to remember 23 steps. So then I went and changed them all to be just text. And you said, well, you forgot one step. You should have deleted the other ones. But maybe as a true way to do it as a Perl programmer, there's more than 2 ways to specify the option. So I left them both in. Okay, another thing I did is I wanted to not have to keep finding, where are these darn scripts I have to run? Have they changed disks? So I had the Perl create the scripts on the fly, specific for each step. So here we're creating the directories if they don't exist. We're doing a here document with single quoting because I have some environment variables, and a lot of work goes in there just to make sure that it could get submitted to the farm. It has to have a shebang there. I use C shell because I like the format of its time command. There's some stuff I left out. And we might have to go in and set some limits on stack size or something. We had to do that recently. And embedded in this time command, you can see it's sticking something in the times directory. This script lives in the scripts directory. And the tool is going to produce a log at the very end in the logs directory. And the farm is going to output a log in the logs directory. Just having that organization up front just made writing the code straightforward. And so I have 23 steps that look like this, but this is one of the simpler ones. So if I'm at the memory pin step, I output some status, I build a regular expression, and I got tired in my VI of as soon as I started putting quotes in, it would get unbalanced and change stuff. So I just made single quote be $Q and just built it up that way. So I build the regex with single quotes, build the sed command, then send it off to system. And that's a preparation step to get ready to run this dcshell.memory power script that I explicitly just put in a hash and then pass it to this run local or on the network script. And at the end, it dies if it didn't find the output file it was supposed to find. Some steps have a really defined output file, and if you don't get that file, the step failed. Other steps, it's much more hard to determine whether it's correct. And so here's an example of that. If after we run local or network for the conformal step, it goes and maybe it's hard to see, but these are backticks. Does an egrep for a certain string in a certain log file from the tool, and then it counts them up. And if the miscompares are 0, then we passed. And so some steps have a post-processing step to say, did it really run correctly? That's the maybe hard part in software, but definitely hard part in software. A certain tool will run, and it exited correctly, but did it really run correctly and completely? Another problem we had is we had these 23 steps, and some of them had to be run in the window configured one way, and some run in another window. There were like 4 different windows or tabs you had to run different steps in. So inevitably, if you would change your focus to the wrong tab, a step would fail because the tool wouldn't be loaded. And since this DC shell tool occurred the most often, I put in a check that if the step you're running, this is the beginning of run local or network, it checks the tool. If it's DC shell, I do a which on DC shell and check and see if I get an error condition. If I get an error condition, I sort of say politely, run this in the right window. I could have said RTFM, but I said run this in the right window. And then you see we do something about calling get resources required. Another thing that's hard to do on some of these steps is feed it to the farm with enough memory requested for it. So if you remember, there's a times directory, so I call this, it turns the script file into the times file, and if the file is there, then it starts reading it and just looks for, parses out sometimes, and gets the memory. It's in there somewhere. And then I'll use that when I do the farm request. Give me a job on the farm with this much memory. You kind of keep our IT police away if you do stuff like this. Okay, now this is the other part of the run local or network, and it took me a while to find IO pipe. I hadn't used it before, and I was doing stupid stuff like just doing the system call and putting it in the background, but that's not what I wanted. I wanted a pipe. Finally, I found the right documentation, and I built up a command that's either just the raw script or it has a batch prefix to it that's going to have the memory request and how much memory and all that stuff. And then it constructs the pipe, specifies the reader, and then processes the pipe like it's a file. I call it $line. I first look for the job ID because I'm going to use that in the subsequent searches to know when it's been assigned to a computer, when it's then actually started, and then that it completed, and what status. And I sort of developed this script line by line and tested it out incrementally, but I wasn't getting anything. One, because I hadn't redirected standard error, and then two, because I hadn't put in this else. This is where you're going to get your underlying tool output from. It's just going to come out in that clause. And once I did that, it worked nicely. Okay, and then some of our steps take a lot of preparation. And one of the things we have to do, some of our underlying tools use Tickle, is what drives them. We just have this big Tickle script, and there's certain pieces that you have to change. This particular piece of code is trying to find some G scan clocks setting, and it calls something to go grab a report file and get that information, and then it essentially replaces what's there with the beginning of a Tickle list, and then it does a postfix for loop to iterate through the clock hash table and print out the names, and then it closes Tickle. But that's like 5 or 6 lines for one variable in one Tickle script. This happens to be from our most complicated step to set up. It takes 150 lines of Perl to prepare all the files and get it ready. Okay, now I talked about getting this clock information from a file. Perhaps you have information in a spreadsheet. Engineers and engineering managers like to put things in spreadsheet. They like to track status and yell at you for not getting anything done last week. Kind of stuff. That sound familiar? So if you haven't used it, there's a CPAN module spreadsheet, XLSX, and I would recommend, all the fun here is in the for loop, and I would recommend putting all the ugliness in one line. That XLS data is buried like 3 levels deep. And just name them some meaningful variables, because like in this example, you might do some filtering. You might not want all the entries. You might just want the ones that are 4 or greater. And then I build up this array here, EDTs, with a hash table automatically with some short but meaningful names. And then I'm not going to show you what I do with this table. Rather than getting in that app note that's 20 pages long, it says pick an EDT that's appropriate for your design. I have a Perl script that will read this and search, essentially solve a mathematical problem. But if you're in managers like my managers, their spreadsheets are complex. They aren't as simple as just a bunch of numbers. Here is a simplified version of our hardware design tracker. So each block is a portion of the hardware. So physically, it's a portion of the hardware. This top has this processor. The processor might has a replicated subprocessor, and there might be a core or base processor that's further down. If you have a hard time thinking about the hardware, just think of it like directories and subdirectories. And so what I wanted to do was, one, get these names from the database and get what level they are at. That's important. And the Perl is just a little bit uglier, because you have to skip over rows that are non-numeric, and then if they're numeric, you don't know whether it's going to be in this column, this column, this column, or that column. And so that's where all the nesting is. But basically, I will know what level it is, and for later, what row it was in the database. Those are two things that are important. Okay, so what took even more software skills was then saying, oh, what I really want to know is for a given block, what blocks are children of it? And this section here essentially manages a parent array as a stack, and as you walk down deeper in the hierarchy, it does something. But if we had a fifth block, it could be here, it could be here, it could be here, or it could be another level 1 block. So it took me like a whole day to get that 15 lines of code right. It's knocking the software rust off of me doing that. So you can look at that if you're interested, but basically, if it's not in the hash table, I stick it in the hash table with the information I have. I don't know its children yet, but then whenever I process a block, I push it onto the children key in its parent. So sort of complicated structure, but not too complicated. But then what it allowed me to do in Perl, I could get the block, I could get the children, I could do it for each. And do whatever I needed to do to prepare the files for the next step. Okay, this last thing is just information on writing spreadsheets. It's a little bit harder, but I have never attempted to write a complicated spreadsheet in Perl. What I do is take the 1 or 2 or 3 columns that are going to change and write a new spreadsheet of just that, and then put it on the user or me to copy and paste it into the old one. And the most important thing here is when we're writing to this worksheet, I know what the row is, because if you remember, I saved that when I read the spreadsheet. So I do data, I update it, I get a new delivery from our customer, update the data, I can write out a little narrow section, and then you have to manually paste it in. Okay, so this is just a list of kind of the Perl 5, if you haven't noticed, constructs we used. And just to give you an idea of the scope, there's a little database maker that reads that big spreadsheet with all the levels of hierarchy. That's a little over 100 lines. Setting up the windows for these tools is somewhat complicated, and for one of the tools, it includes when you would do the cloning step. That's a 3-step processing. Cloning is just a sub-step of one of those steps. So I had to write a 200-line Perl script just to do the setup for all the windows in a easier way. I wrote a 400 lines of code just dealing with the spreadsheets, and then this flow thing just kept growing because of the number of steps, and I put a lot of help in there too. So it's like 500 lines before I do anything, but it's almost 3,000 lines in itself. But what it does, it lets me get my tasks done quicker, but what I try to do is develop automation that we can then share across the team. If everybody's using the same script, then you get more confidence in it, and you have higher confidence when you make your delivery to the next team. But that's the last slide. We now have time for some questions.
Are there any, okay, first question is how often does it change? Second question is, are there any tests other than if one of the EDA tools throws an error, you know something went wrong?
So how long does the total process take?
Or how often, and now that you've written this, is it going to be the same way for a long time, or do you update tools often enough that it has to be evolving?
Well, it's kind of stable now. I might add further checks, but a problem in our group is that we tend to change tool sets from one chip project to the next. But in case we don't, I wanted to have a Perl database that we could consider intellectual property that we could leverage and say, remember the flow? We're going to use the same flow. Some of the steps might be different, but it's going to operate the same. But for one person working on a block, it can take as short as less than 1 day, or it could take someone all week on our more complicated stuff. And then we have 23 steps here. They're all other sorts of verification we do to make sure we're done. We weren't something that's close to like Perl Critic, but it analyzes our output and says, you shouldn't have used this cell. This is the wrong kind of cell to use on a clock, and all kinds of stuff like that.
Okay. Beyond just design rule checks.
Yeah. Okay, one quick question? Sure.
Since you've written this script, I mean, I look at this as kind of a parallel universe in my way. It being a sysadmin, and you know, a lot of other people very technical, but nobody writes code, right? Have you got like a replacement? You know, you get hit by the proverbial bus, that type of thing. Logistical, I mean, your job has changed.
I will say it is in my best interest to assess people's ability to code when we have them as interns and when they on board. And I do have one person who's reasonably competent. I don't say he could replace me, but I can assign him pretty big tasks and he can do it. But that's the kind of thing. We supposedly have other groups in a company as big as Intel to do that, but
Well, and that's what I was thinking, is that now your logical next step would be, you know, doing this kind of a process for the next team that you're handing off.
ideally, we tried to use the other team's flow before and it's driving us crazy, so we're actively seeking another flow, but you didn't hear that from me. All right?
So you're not actively trying to get into that flow to take a bigger chunk, hand this off to somebody else?
Well, I am going to present it to another team in Munich, but we're trying to use their maybe Python flow for other stuff, so that's why I've been sitting in the Python classes.
Sure. I understood.
Yeah. All right. Thank you.